Hello everyone. We'll get going in just a couple minutes here. Just a couple minutes. I'll say some hellos as people come by. And then I'll get started with the housekeeping in just a bit. Oh, I'm in the wrong channel. So we're in the live broadcast chat channel of the Discord. If you want to join the Discord, you can go to the URL adafru.it/discord and say hellos there, or the YouTube chat. Hi, Beata. I do have the other Twitch and LinkedIn and X chats get funneled into Restream, but I do not have those on the screen. It is the most Friday of Fridays. Is what it feels like. Glad Beata could make it. Hi, Taya. Hello, Hams. Oh, Hams Labs is typing. Getting ahead of the game. It'll turn 2 o'clock and we'll get going here. I started a little early because you never know when it's not going to work. Not too shabby out there today either. Hamslab says, I hope all is well with everything for you, especially the new child on the way. That's a great segue, Hamslabs. So let's get started and we'll talk about the new child. So hello everybody, my name is Scott. I go by Tannewt online and I work for Adafruit. Adafruit is an open source hardware and software company based out of New York City, but I work in Seattle here. I have my own office space where I do streams, usually these deep dives at 2 p.m. Pacific on Friday afternoons. They go about 2 hours. I'm happy to answer questions and go on tangents and just kind of like try to transfer my knowledge to folks who have questions about it during deep dive. That's why we're, unapologetically technical, I guess I would say. I usually am working on CircuitPython. CircuitPython is a version of Python designed for microcontrollers. Here's an example of an Adafruit feather. So the board is the feather. So this is Adafruit designed, usually Lady Ada designed. And then the chip on here is a little tiny computer with RAM and a CPU and all that stuff. And it runs CircuitPython. So you plug into the USB port, shows up as a drive. It's got Python code in human readable form that you can just go ahead and read and edit, and it just automatically runs and goes. So that's usually what we're working on in a deep dive here. You can see Adafruit Feather here as well. But the last 6 weeks, I've been working on a thing called CircuitMatter. So CircuitMatter is a library for CircuitPython and regular Python that's designed to implement the Matter IoT spec. So the Matter IoT spec is the end game, hopefully, of home automation, IoT, internet. IoT is Internet of Things protocols. And so I've been working on that, and we're going to wrap up today. The reason we're wrapping up with that is because, as Hamslab said, I am expecting my second child any day now. The due date is on Monday. So chatting with Lady Ada and folks earlier in the week, they were like, why don't we just call Friday your last day instead of having this, like, who knows when it'll be. So this will be my last deep dive for a month at least. Maybe I'll do a couple after Thanksgiving, but before the holidays. But we'll see. I did check in with Foamy Guy, Tim, whose name is Tim. And he said that he'll be able to cover deep dives while I'm out. So this 2 p.m. or so slot should be covered for the next month or so by Tim. So thanks to Tim for doing that. And he usually is doing more CircuitPython library level and tooling stuff. So that's also interesting and super important to the CircuitPython ecosystem. So that's where we're at. The baby is not born yet. Otherwise, it would not be here. But like I said, the due date's on Monday. So this is my last day of work. And after this, I'm going to go buy shoes. So I'm pretty much done after this stream. But I do like streaming, so my plan is to kind of show you where I'm at, what I've been doing this week, and taking questions. And like, I don't really have much that I'm working on because I'm kind of done. So if you have questions, now's a great time to do that. I was actually thinking maybe I'd do my DigiKey peruse the dev kits that are available now too, just because I part of my role in CircuitPython, I think, is kind of like providing some longer term vision about what CircuitPython should be and kind of prioritization around what we should work on next. And I always like to like keep an eye on like new development kits and stuff in terms of that. So I like to kind of get that all in my brain and let it stew. So that's a good thing to do even while I'm going to be out. And in fact, being out can actually be a chance for me to like kind of follow my desires. DCD says, I noticed you updated CircuitMatter on Git. Yes, so let's go to the desktop and we'll talk about where we're at CircuitMatter. I'm quite happy. So the summary is I have to give OBS permission for my desktop again. So just a second. That should be good. Now you can see it. So I did rename the repo a little bit to capitalize the C and the M. And this is, the reason I did it is it's actually an accessibility thing for screen readers, I think. So a screen reader will, I believe, read off circuit capital M matter off like I say it better than trying to kind of like, it like does a better break. And that's true with CircuitPython, I think, as well. So I just renamed the repo just capitalization-wise. And you'll see that there is a release here from 40 minutes ago. So I got the RGB example working. So if we go to the bench, I showed this on show and tell. So there's a Raspberry Pi 4 here. It's wired up to just a single NeoPixel that's behind this thing, trying to make it a little easier to see. And then if I just pull up, so this is what I was trying to get working last week, was the Raspberry Pi stuff. So here's my phone. And if I see Pi NeoPixel, I can turn it off and on. I can click into it. And I don't know why this color's wrong. Brightness should change. And then if I hit purple, like it'll get back in sync. I thought the syncing was fixed, but I'm not sure where that color comes from. But it's working quite well. Like the app gets a little out of sync with the stated device, but at this point I don't really care. I'm a little dunzo. But yeah, you can see that overall the app is, it does this weird thing is if it's too far on the outside, it goes back to the middle. But you can see that I have the RGB working. And I could just leave the Pi NeoPixel on. I see it's showing, like the colors aren't right here, and I'm not sure why. Not sure why that's not right. But yeah, it's working quite well, I think. If we go to the terminal, this is the output from that. And I thought it might be, the issue might be this hue and saturation, but I think I'm reporting it straight back automatically, and it's still not really, it's not really going. Ty says, did you carry on with the Pi 02W or jump over to the 4 for the easier use? This is running on a 4B. I don't remember. I think the 2W just wasn't working, and I didn't bother to do more into it. One thing I'll note is if I Control C it, because I'm doing NeoPixel. Oh, you can't see my desktop. Go to the desktop. On my desktop here, you'll see that the command I'm running is sudo. Hi, Mark. Sudo, and then I have to pick the virtual environments Python, because if you do it without it, it doesn't work. And then just running code.py. So if I just run it again, it'll start up, and then it'll print some errors if I try to, if the Apple Home thinks it already has a session, it'll try to communicate over that old session. But the new, hi Paul, the new instance of the CircuitMatter stuff won't have the old session. So it takes a little while for it to time out, and then it starts a new session. And this should be it reporting all of the current state. And it says updating. It's following my eye, but I don't know what that means. I don't know what it's waiting for by updating. Because I am sending, I thought I was sending all the state back. Oh, and it's actually, the NeoPixel is off. Why isn't my NeoPixel showing anything? Maybe my Pi is broken? I'll tell you, I'm very excited. There we go. I'm very excited. Let me go back. I'll just show you the bench briefly here. I'm very excited to get this running on CircuitPython. Just because I much prefer CircuitPython over the Linux Raspberry Pi stuff. So this is working, and I am running it from the PyPI installation. So here's CircuitMatter on PyPI, and if I refresh, there's 0.4.0 doesn't work. So I did a 0.1, and that works again. Hamslab says, how well do Matter and Apple Home play together? What I'm trying to figure out is if I can use an ESP thread border router board instead of a HomePod MIDI as a hub in a way that is seamless with Apple Home. I wouldn't expect that to work. I think that the controllers are very app specific. I think if you want to work with Apple Home, you've got to use something that Apple Home supports for the controller. I think you'll need a HomePod MIDI if you want Apple Home support. It might be possible that if you get like an Apple device that doesn't have a thread border router but use it with the ESP, maybe it'll work, but I'm not sure. I haven't learned a lot about thread yet. So I would say if you want Apple Home, get an Apple device. Because I think like the way that it's interoperable is that like you basically like devices can be members of multiple fabrics. And so if you want to interoperate with the ESP thread border router, the ESP controller stuff, and then Google Home and Apple Home, like that's actually 3 separate networks that all that device is all on at the same time. And those controller devices put you in kind of the app ecosystem that you're interfacing with, I think. It's kind of silly. Trevor was looking at adding It's-a-Snap support for HomeKit devices, and turns out there's a Matter API as well that you can run from Apple, but I think that means that you need to commission into your, if you use the Matter API in your app, then you are establishing a new fabric, and it won't, like the apps themselves don't interoperate. So yeah, but if he uses the HomeKit one, then you don't need to commission again. You just use all of the devices that HomeKit knows about. Clear as mud. Then just talk about thread and stuff, and that makes it complicated too. All right, so a lot of what I was doing is after I got that working, let me go back to the desktop. What I was trying to do is kind of standardize the setup for releases and things, and I was documenting it here, so there's like examples and kind of explanations. An example of the QR code. This will not work for you, so you'll need your own one. If you have iOS 18, you can add and control Matter accessories to the Home app without a Home hub. Hans Lab says, thanks, maybe I'll take a look at Homebridge on the Raspberry Pi. Yeah, I'm not sure how that works. MC Quinman16 says, hey Scott, did you make the CircuitPython powered Gameboy cartridge? And if you did, is it possible to make a CircuitPython powered DS 3DS cart? So I've never looked at DS 3DS, so I don't know. And the CircuitPython powered Gameboy cartridge I made originally, I was actually I just plugged one in today, but it never got manufactured. And the SAMD51 I think was a little not quite good enough to do it. My hope has been to redo it with RP2350. And in fact, Lamore was talking about doing that today. So no promises. It's not out yet. Don't ask, but it is something that's on our radar. I know John Park has been doing some Game Boy stuff too, so we're thinking about kind of where Lamore is thinking about what she wants to do in that space. I'm going to be on leave, so we'll see what gets done while I'm away. Okay, let's see what this says. Update your iPhone or iPad to the latest software. Without a home hub. Oh, interesting. iPhone 15 Pros and 15 Pro Maxes, and later you can control thread-based accessories without a hub. Oh. Add accessory. If your Matter accessory was previously paired to another app, tap More Options and then select your Matter accessory. So it must be running the Matter controller on oh, here we go. Or a compatible third-party thread border router. Thread-enabled iPhone devices running 18 are able to locally pair and manage thread accessories, which may require an update from the accessory manufacturer. My wife has a 15, I think. So yeah, maybe it would work. I haven't tried it. Questions are great. Keep them coming. So I've been trying to standardize, and one thing, so I elaborated here, and then I realized what it would be really nice to have is read the docs. So yesterday I was working on getting read the docs rendering. So if you go here, I don't know if people know this, but if you click this docs passing icon on any of the CircuitPython repos, it should take you to the docs for a given library. And this is a copy of the README. But then also what you can do is you can start to browse like all of the, well, I don't have a lot of docs. And some of them aren't great, but it at least has some of the APIs set out. And I think the ones that are most interesting are actually the device types. Because the way it works right now is you subclass a device type. So you'll see on off here, I said it's a light that can be turned on and off. Unfortunately, on and off don't render well here. So part of what I did yesterday is I figured out why these render as attributes when they should be rendering as functions. And I made a pull request to the sphinkx-autoapi folks that I'm using that fixes it. They were basically, if in a init you did something like this, where you do self.foo.bar equals 1, it thought you were assigning bar to that like outer object. It wasn't being specific to make sure you were only assigning to self. And it turns out it also included local variables. It was just like catching stuff it shouldn't have. And that was masking on and off functions that were defined on the outside. So here I actually have a local build. So if we look at the local build for on and off, it's also broken. Maybe I need to do another local build. It should be fixed. I was doing it with the test, so. No? Uh-oh. Maybe it's because I fixed a different issue. I'm on the wrong repo, that would do it. I need to be in under init fixes. Now if I run. Paul says, I'm working on writing docs for an open source project while I listen to your stream. Great. I am bad about docs. That's why I do a 2-hour deep dive where people can ask me questions. But did I show the code that runs the RGB light? I don't know if I did. So if you look in CircuitMatter now, there is an examples folder, and if you just do one RGB light, so this is what kind of your code.py equivalent is. So copyright, import board, import NeoPixel, and then you'd say, I'm going to make, so the way that you hook into like the commands that get done over Matter is by subclassing. So I'm subclassing this extended color light thing, which is like defined by the Matter spec. And now I have some like custom state that I'm doing. And then the way that extended color light works is it sets color RGB when the color's changed. And so if we just want to read it, I return the color. If we want to set it, I fill it. I do a fill over the NeoPixels. And then same with brightness. I set brightness, I return brightness, and then I set it, and I also set it for the strip itself. Because if on and off are called, I set the pixel strip brightness to either the current brightness or 0. So that's kind of how you hook in your custom thing into the Matterland. And then to run it, you do CircuitMatter, and then you say, well, starting the NeoPixel, and then construct the device. So this is a subclass of a device. And then you add that device to Matter, and then you just loop processing packets. And you could theoretically do other stuff in this loop too. But I'm not right now. So that's for 56 lines of code to get an RGB light working. This whole RGB pixel class could actually be factored out into another library, or I was even thinking about putting it in CircuitMatter itself, because this class actually doesn't care much about like how the pixels are actually implemented. It just fills the color and sets the brightness. So like dot stars, NeoPixels, the new one that Jeff just did, anything that is a pixel buff descendant, like will just work, which I think is really neat too. But then you could also do things like you could pass in half a strip to 2 of these, and then you could have 2 different colors on the same strip, that sort of thing, if you wanted to as well. So that's what CircuitMatter code looks like. That's where I kind of wanted to be by the time the baby came, and we're there, which is great. The next big thing is getting it on CircuitPython, because that would be really cool. And we're going to find some like Pythonisms that I am using in it that we don't support in CircuitPython yet. So I rebuilt the docs. Let's just see if they look fixed. And they do. So this on and off, it's cool. You could actually mark it as an abstract one. And it says, oh, it's called when the light is turned on and called when the light is turned off. And the abstract is so like, if you want to figure out what kind of devices you could be, you can go here. And then if you look for like extended color, you can see that color RGB is an abstract property. This is a bug. This is the other bug that I've fixed. And in fact, I wonder if I could just git merge my other branch in property template. Hopefully they don't need me to fix anything. I fixed that bug too. So if I rebuild, it should fix the formatting of the property. It's missing like a new line. So the way that I'm using AutoAPI to do this, it's still not right. It's like slightly better. We're probably missing yet another new line. So the way that this works is it's parsing the Python as an AST, and then it's traversing that to figure out what happens. And then it's spitting out the templates, but the templates are not quite correct. So it generates RST, and that RST gets then processed through Sphinx. AutoAPI is the same thing that we use for CircuitPython docs, like the core docs. So AutoAPI, CircuitMatter, device type splitting, extended color. And we can see here that brightness and property. I wonder if this abstract method is incorrect. That might be throwing it off. It might need to be like abstract property for AutoAPI to do it right. The idea being that like you want to show that you can override color RGB to get something, and brightness should actually be abstract as well. The idea being that you could browse these docs and see what is abstract and know that that's what you can subclass for your custom behavior for that type of device. And then the examples are here. They're just like verbatim in here as well. But this is just a good, I mean, I didn't do a lot of docs, but at least it's a way to like browse the structure without being in the code. And it's inheriting some of these for, yeah. And that's actually one thing I could do today is just write class doc strings. But honestly, that also doesn't sound like very much fun. I don't know. What would you like to see? Should I shop on DigiKey? There was a bug that I was thinking I'd look into. Oh, I was kind of curious when I was switching how it does releases. So it used to be that you had to use a program called Flit, and I switched it over so the CI can do all of the releasing for CircuitMatter. Sorry for the siren, it's on my end. Seems like they're going right by. So siren is on my end. Ooh, window cam. Can you see oh, there's the fire truck. I don't know how far they're going. It's the ladder truck. Ari would be excited. Sorry about the sirens. At least we got to see the thing. Yeah, maybe I should just do like class docs. The other thing that I know that stylistically I need to do that I haven't done is I'm not super consistent about capitalization for like different attributes of different structures, because in the Matter docs, they're always kind of like, the words are all squished together with capital letters to separate them, where in Python land, that's how you do classes, but not variables. And I've been a little inconsistent about where I draw the boundary. I was kind of like trying to be like, if it's related to the spec, then it should match the spec's capitalization. But if it's on the Python boundary, the Python API kind of edge, then I want it to be Pythonic capitalization. And I'd really like to figure out how to enforce that automatically, but I haven't figured that out yet. Maybe that's what I could do too. Because I've definitely, one of the main reasons people argue against property use is that you can inadvertently think you're using the correct one and you're not. So you can, if you're trying to use on, off with capital O's, but you use on _ off instead, like you can assign to on off and it'll just work, or it won't raise an error, even though it's not the one you meant, which I found I had a bug for that. So, what do I want to do? It would be kind of cool to, I wonder if Ruff can check capitalization. And I realize you can't see me. Let me finish typing. I definitely want to go to DigiKey. I'm curious. Beata says, amusingly, there have been times in chats when loud rumble a car or motorcycle goes by on my end, and then a second or two later, another goes by on the other end. Miroslav asks, hi Scott, will you work more on CircuitPython for the ESP32P4? We definitely will. We definitely will do more CircuitPython for the P4, but probably not anytime soon. I kind of think like we'll want to get CircuitPython and add support for things like DSI when we're actually going to release a product. But to do that, I think we're kind of waiting for the new rev of the chip that has some of the stuff fixed. Like right now, they're still kind of engineering sampled. So, well, that, and I'm going on vacation. It's not vacation, it's parental leave. But I think we will, but not soon. If you want to do it earlier than that, then you should do it. Taya says, if anyone wanted to add another device type, like a temp sensor to their RGB CircuitMatter device, would they just look up the correct characteristics to support and add their new class to the device? Yeah, so that's a good question. I don't know. So there is a pending PR. Whoa. There is a pending PR for circuit, for a temp sensor. And I'm not exactly sure how they work. I was thinking about this. So there's a pull request from Ludovic, I think is their name. And this kind of shows like what is needed to add new device types. So although that assumes that the mechanics of CircuitMatter cover all of the functionality you need, which may not be the case. But basically there's two components to it. There's like two layers. There's devices, and then there's clusters. So a device is made up of a number of clusters, and then those clusters get interacted with. So what Ludovic has done here is added a definition for a temperature sensor device. And then what they're doing is what you do is you construct the individual clusters. You add them to this servers thing that then gets it wired up. When you do the add device, it wires it up into kind of like the mechanics of CircuitMatter. And then they just set one random measured value there. And you can see here for clusters, you give it cluster IDs and revisions, and then number attributes. I don't actually know if they're waiting for me to. Looks fine. Okay, let's actually merge this in. It looks fine. Or you know what? What we could do first is let's actually show you how these two things match up to. Well, one, this is just a random measured thing, so we're gonna have to figure out how to change that, how to connect that into Python land. But so there's two parts of the spec. There's like 3 documents for the Matter spec that, as far as I can tell, matter, that you should look at. There's the core specification, which is like the interaction model, the data model, the encryption stuff, all of that. And then there's this Matter device library. So this is the thing that establishes like extended color light. It says an extended color light is a lighting device that is capable of being switched on and off. The intensity is adjusted and blah, 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 blah. And they have this notion of superset. So it is a superset of this. And in Python terms, that means that it can subclass the superset. So extended color light is a superset of color temperature light. So I use Python like class hierarchy to do that. And then if we look in here, smart plugs, switches, and controls devices, and I want to have each of these chapters be a particular folder in CircuitMatter. And then they have temperature sensor device. So this is what the PR is doing, and it's revision 2. So we could go look at the PR, and this revision is actually wrong. Revision 4 is not valid. The revision for the revision in the device library. So this is for Matter 1.3. The revision value should be 2. The ID is 0302. So we'll go here, and that is correct. It wouldn't work without that being correct. I'm a little surprised revision doesn't mess things up. And then it says, okay, there's no superset, so there should be, it is a simple device. So that's what the subclass here for simple device is. If it was a superset of something, then that would be an intermediary. And then it just has identify and temperature measurement. And if we look at here, it says cluster requirements. It is a temperature measurement server and an identify server. So that's what the init is doing. And that's all. Like that's what defines a temperature sensor. You can see this is 7.4, and then 7.5 is a pressure sensor. So now what you need to do is, what you actually largely care about is what temperature measurement cluster is. So you open a different document that's Matter application clusters. And then let's find temperature measurement and sensing, the temperature measurement cluster. Interface to temperature measurement functionality, including configuration and provision of notifications. Okay, so this says attributes, measured value, which is what is implemented, minimum measured value and maximum measured value. And these qualities mean something. X is nullable, P, I don't remember what P stands for. And they're only read-only. They are nullable. Oh, and that's it. Pressure measurement. It is a base. It has the application rule, endpoint, and a TMP. It's a PIX code, whatever that means. Ah, good question. DCD says, where are the codes like P defined? Good question. They're defined in the third document, the core specification. So if you look for, there's permissions and then there's qualities. And I think it's in chapter 7, data model specification, data qualities. Just there's also this notion of conformance, but that's not this. No, so this is the separate column. Let's pull it up again. Yeah, so these are for conformance, but we want qualities. So if we go back to the spec, other qualities here. So this other qualities is matching some random letter to what it means. F is for fixed, I is for singleton, C is for changes omitted, K is for diagnostics, large message, non-volatile, and P is for reportable. If best effort reporting is supported, then the attribute supports a reporting configuration. I don't know what that means. I don't know what reporting means. There is some event stuff that I have not implemented yet, which totally could be it. Hi, Tomcat. Nullable, I definitely had to implement. But I don't know what reportable is. It might be event related. Note that clusters do have these global elements are additional attributes on clusters, on every cluster. So the root cluster type defines most of this stuff for you and maintains it. Here's event. Event records. 778. P is 777. 77 has the table. Oh yeah, does 778. Reportable quality. The subscribe interaction supports all attribute data. This quality is supported by other interactions that only require attribute data with this quality support interval or change reporting. Oh, subscribe interaction allows you to subscribe to events. I don't have event support yet, and I wonder if that's what what the problem is. An event defines a record of something that occurred in the past. Oh, absence of a quality column implies that the event does not support any qualities. So I think it would actually be listed under cluster as something separate. So temperature only has cluster ID and attribute. But if we look at like messages clusters, it has events as well. So I haven't implemented events yet. Message queued, message presented, message complete. Yeah, so haven't done events. Generally, I work towards like when I want to get something done. Like I have a goal of like, this is the device I'd like to do. And temperature or sensors in general are the thing I would like to do later. But yeah, I was thinking that maybe like on a measured value read, we would actually want to go all the way to the sensor. Because there's no commands, it's just the attributes. So what you'd actually want to do is like, when a matter read comes in, you'd want to do the read and reply back. The other way you could do it is you could have just your actual temperature sensor like being read and assigning it, and then the read would just get the latest value you got. Does that help answer the question of like how you would extend it? In theory, you should be able to like auto-generate a lot of this stuff, but the thing of like how you actually interact with Python land is kind of like still up in the air. But kind of what I've been thinking is just like when like you do an abstract temperature property, and then when you do that, you just read it. I don't know. Haven't gotten that far. Good question. I wonder if I should just merge this in anyway, because I'm going to disappear. I think I will. I'm going on leave, so I'll merge this now. One other thing about this that was good is I did set the permissions on this repo, so like other Adafruiters can work on it. It has the CircuitPython librarians ability. But let's just get that merged in. Ty says that makes sense to me in the read sensor and property request accessor. Yeah, I kind of wanted to think of it kind of as like what I think of as like an RPC, where like some transport is doing all of the like the work to do it over the network for you, and then on Python side you just like, oh, if you want to implement an attribute and do something when something's read, you just like you use a property to do a getter and setter. Or if you're trying to implement commands like on and off, then you just subclass and do those functions. The min measured value is an arbitrary number. Did you notice they use out-of-band data as special flags? I have not, and I don't know where that number comes from. It's kind of weird to me. I wouldn't be surprised. It's got a lot of weird legacy stuff to it too. Okay, so I'm waiting for the sphinkx-autoapi people to merge in my fixes before the CircuitMatter docs will be slightly easier to read. I'm a little frustrated that property still doesn't look great, but it looks right there. Abstract on and off is nice. Some of these I'm like, maybe I should hide them. Like servers is kind of an implementation detail. Rough capitalization. Variable. Checks for the use of a non-lowercase variable name in functions. The PEP8 naming linter. Oh, am I just not turning it on? Oh my goodness. I think if I want to do it, can I select N and then get a lot of rough errors? Rough. Check. Yep. Only 91. Those ones aren't. This is all this lowercase stuff. That's actually not as interesting to me. Variable CA and class scope should not be mixed case. This is the thing that I've been debating. Should I match the definition in the spec? Should not be mixed case. Or should I just make it pass? Like, the problem is I'm not consistent. And I should be. But should I be consistent in Python land? So here's an example. Here's how I'm handling those qualities. Is I actually have like the capital letter and then underscore. And the reason I did that is to match the way the spec has it. Spec/readability over linters. Okay, if that's the case, how do I enforce it? I want to enforce the wrong thing then. Is there a heuristic that would help the reader to transform from Python-like names to find thing in the specs? Yeah, there is, right? So like the way that Python wants it is just like if it's initiator random in the spec, right? So like if we find, well, measured example is a good a name too. Initiator random. Let's see if we can find it. No? Sometimes PDF search does not work. It is in, oh, I'm in the wrong one, that's why. Yeah, so this is what, like, oh, here's the message, it's called this, and here's the names, like, it kind of makes sense to do that. But what I would like to do is that this is a TLV structure. I kind of want to be able to tell Ruff that, like, if it descends from this particular type, then the capitalization should be this style. Which I think would be derived from the PEP8 naming linter. Ignore names and extend ignore names. To ignore all names starting with test or ending with test, you could use that or that. Static method. Extend additional ones. Can you build an exception spelling list for Ruff? I could probably just do it by name, but then that, like, I really do want to, like, scope the capitalization based on, like, subtype or, like, class hierarchy. Like, anything that's a TLV structure gets this. Anything that is a cluster gets this. Anything that gets device type did not. Because device type is like the Python, like really the Python part, but cluster and structure derivative stuff should be. I wonder if I could do it based on. I wonder if I could do it based on like file structure. What tools would help determine the derives from? I think Ruff is doing some type inference, but maybe not. But I wonder if we could do it based on folder. But I really want to like, I want variable name in class scope should be mixed case. Although I wonder if class name should be cap words. Is there an ignore namespace, like you say in a file structure, which would make me think of a clever glob pattern? Maybe. Pep8 naming. ruff.toml. pyproject.toml. We really want like rough settings by subdirectory. The opposite should be assertion sounds problematic. MC Quidman says, would Matter work on PC like my Windows PC running Python or some other programming language? So mostly. So it's mostly straight Python. The challenge you'll have on Windows, which I do not run Windows and I haven't looked, is it uses MDNS to do device discovery, and I don't know how you can configure that from Python on Windows. So it won't run on Windows as is, but it wouldn't be potentially that hard if there's an way to do MDNS. If you look in the CircuitMatter repo, so for CircuitPython, we'll also have to replace the way MDNS is done. So if you look CircuitMatter utility MDNS, there's like Avahi, and Avahi is a thing that is like Linux specific. So you would need a different one here for Windows. And Mac probably needs another one too. Enter plugin configuration. Here we go. Config file discovery. Ruff supports hierarchical configuration such that the closest config file in the directory hierarchy is used for every individual file, with all paths in the config file being resolved relative to the directory containing that config file. Ruff does not merge settings across configuration files. But you can explicitly inherit from others. So I wonder if we did, So we have a ruff.toml at the top level, but we also say like, okay, in clusters, it's really in device types where we care. So what if we remove it here and then we say in device types, we put a new file that's ruff.toml, and we want to extend equals, I think we're 2 up, and then we want what is the name of that? Select lint. There's extend select. So we probably want extend select. Lint extend select equals n. So what this should do is it should run it. We should have fewer errors. If I worked naively on my Windows PC, it would be cool to have my status of my PC accessible via Google Assistant. I'm going to duplicate this file. Yeah, I'm excited to see what people do with this. Let's see what happens now. It doesn't seem to have worked. Is it extend select or select extend? Extend select. But I wonder if I need to combine these and then let it override it. No? I don't know. I've not done much rough. Why didn't it say? Oh, this is the wrong file. So, what is the preview that's not enabled? It's for rough. Must be after check. So it's like certain settings that haven't been turned on that are only in preview. Well, that didn't work. Why is that? It's 2 up. There's a rough cache there. We're doing extend. Extend select. This is wrong. Huh? So it is running it. But why isn't it complaining about the cluster stuff then? Because I thought I put it in clusters too. Because, like, it should complain about a lot of these. Huh. So it's okay with the capitalization. Well, that's annoying. Editors, rules. Can you make a custom rough rule? Maybe not. Custom rules for it. There's no plugin system. How such a system could be implemented. AST grep, and it's pretty fantastic. Yeah, we could just do a separate check for it too. Anyway, it's not going to happen today. So, sorry. But those are the sorts of things that I definitely think, like, it's not worth making uniform until I can guarantee that it's uniform. That makes sense. So, like, it's not worth worrying about it until I can programmatically verify that I've followed the capitalization right. Plus, I'm out of time. It's fine. I'm a little tempted on the MPY cross thing, but maybe I'll just shop on DigiKey first. Any other questions? I'm gonna do my normal check for I see kits, is that where it is? No. Dev kit. Let's dive into new products. All right. Let's just see what new stuff is on DigiKey here. FPGA is usually a pretty bare 13 things, sort by price. Green pack, max 1000, almost feather shaped. It might be more like what? Gate mate. Isn't that open source? 58's not too bad. Tang primer. Mach X02. That's the one I thought we could do like a stemma board with a Mach X02. Now we're over $100, and then FPGAs quickly get very expensive. This one's $8,000. And that's not even the most expensive. The most expensive new FPGA dev kit is $17,000. Can probably do pretty wild stuff with it though. I wonder. I-series transceiver sock. That's an Intel one. Yeah. That's basically what they use for like designing new microcontrollers. Is you run it on something like that, I think. Okay, that's not that interesting. MCU DSP. In stock, new product, exclude, marketplace. Apply all, sort by price. Adafruit, Xiao RA4. RP2040, WizNet's RP2040 hybrid thing. Trinky, Nucleo. Interesting. I think I have. Oh, this is a U083 and a 31. I think I have one of those. Wow, this one's an RT 1010 Pi Dev Kit. I don't see where it would be, but $11 is very well priced for an RT 1011. Motor controller. RP2030. MCX-A, I think that's what Timon was talking about. AVR stuff. Pimoroni TinyFX. Arduino clone. Renaissance RISC-V board. More MCX. Lots of MCX boards. SEM U0s. RA0. Make your Arduino solder kit. U545. The $11 one did look like a carrier board. It did. I think there's this one as well. For 17, maybe that's more like it. It's probably just wrong. M5 stamp. Arduino Nano 33s. Interesting, they're doing it in that DIMM form factor. Headers. Memento from Adafruit. Must be getting caught up on stocking all this stuff. H7SL8. $36. G473. Interesting that it's got like a PCIe edge to it. Zest. It's just an interesting form factor. Here's the base SOM for the MP1. Scilabs. Beagly AI. That's not the good side of the chip. U5G9. This is the one that has insane amounts of RAM, I think. Like multiple megabytes inside of it. Renaissance Quick Connect. Yeah, this is one with tons of RAM too. Coral Dev Board Micro. I have one of these. Those can't be that new. We're over $100 now. BusyBee. OpenMV. Coral Dev Kit. That's like the single board computer. That looks like a carrier too. Nothing super interesting. Let's check the RF. The RF section is where a lot of the ESP stuff ends up. In stock, new product. Oh, you know, it's in stock as well. That's probably why. I'm seeing some that are like, these aren't that new. Let's see. Apparently people are trying to use a Raspberry Pi / Arduino to emulate a DS cart, and apparently the DS cart's protocol requires very precise timing and low latency. The Pico has special programmable hardware in it, which makes this barely possible. Yeah, it's also interesting. So MC Quinman also says, even if you have a regular Pi clocked above a gigahertz, it still won't work reliably due to running under Linux. So it's also important that the 1 gigahertz only applies to the CPU core. Often the peripherals around it, like SPI and I2C and GPIO even, are clocked at lower rates than that. That's why when you get really high-speed interfaces like high-speed USB, DSI, CSI, it's actually dedicated. It's not only dedicated peripherals, but it's like dedicated hardware usually as well. Like GPIO usually doesn't scale with the CPU clock speed either. You either use an RP2040 or an FPGA. Yeah, it doesn't matter if you're running over a gigahertz unless you confirm that your GPIO can do that. So for example, for the IMX RT10 series, in the 1060s with in the 1060s, like the Teensy has, they have one bank of high-speed GPIO that can do single-cycle accesses. And the RP2350 has single-cycle accesses to GPIO as well, just like the 2040 does, but they only run at 150 megahertz or so. You're probably, like, FPGA land's probably where you want to be for that. Okay, C6. So usually what I'm looking for here is just like which ESPs are here. H2, Arduino AI Thinker. That looks like a render. S3, C3, C6, Alora, ESP32s, S3, sorry for the hiccup, C3, Itsy Bitsy, ESP32, C6 Feather, C6 Quick, lots of C6 stuff. S3 Feather, NB IoT. We're only at $17 still. Itsy Bitsy 30, ESP32, Photon 2 from Particle, Feather form factor. Oh, it's running an RTL. It's not Nordic. SparkFun, C6, that's their version of Feather. Their form factor, Feather form factor stuff. An ST part. I'm really just Nano Matter using Scilabs. I wonder if they're selling many of those. Not a whole lot. Weo Tracker. Asset Tracker. GPS. Nora 306. I don't know what that is. Silicon Lab stuff. S3 box. A new S3 box. Box 3B. RA6 M5. I don't know what fan style is. Like, there's actually like antenna eval boards in here too. Definitely over my impulse. Here's a discovery for BLE audio. That's something maybe we'll do in the next few years. BLE audio. NRF cell kit. Oh, and we're over $100. Yeah, the Nano Matter I think is actually Arduino Nano Matter. I'm going to ask support about BLE audio capture. Yeah, we haven't done any BLE audio. Maybe we would do regular BLE Bluetooth audio first, but yeah. Interesting. So here's the Nano Matter uses this Scilabs chip. Actually, I wonder, they say powerful, but I wonder actually how powerful it is. I wonder if it's MGM240 is one that CircuitPython should be able to run on. I think maybe that's included in the port. It's interesting that it says the Matter color light will be the only officially Matter certified profile for the Nano Matter community preview. So they actually are trying to be certified. And it is thread. It's an M33. Can do Bluetooth as well. Huh. Tutorials. There's one. All right, well, how does it work? Board architecture. It has an RGB LED. And a SAMD11 for a USB bridge. Pinout, datasheet, schematics, step files, form factor, powering up the board, installing the board core. Here's the hello world. The hello world just blinks. Represents the red LED of the built-in RGB. Developing Matter-compatible IoT solutions has never been easier with the Arduino ecosystem. It's only through the thread, so hubs must be a border router. Several Matter examples. Matter protocol. Okay, let's see what this shows. So they have LED off, handle button press. Set up the button, turn off the LED. QR code URL, interesting. Manual pairing code. So they have the manual pairing code in there even though they're not supposed to. Well, I mean, that's not to be certified. I don't think you're supposed to have it. The device shouldn't know what the pairing code is. It's supposed to, or the QR code. And then it waits a delay of 200 while it's not commissioned. Waits for thread. Wait for the device discovery. And then if it's pressed, then we toggle Get the current on-off state of the light bulb. If the current state is on. Oh, interesting. So they're really just polling. They're polling some other state. Huh. I thought about doing it that way. So in this world, it's like, in our while loop, you would say process packets, and then you would check like the other object's state to see if the state has changed, rather than like kind of being in the loop. I think I like being in the loop because like when you call on, if it raises an exception, I have code that says if it raises an exception, we actually propagate that error kind of back. I wonder what they use for that. Or what website it links to. Nice. Those are handy. How to get paired. Decommissioning. Here's a temperature sensor. How do they do it here? So they have the same setup, and then they just loop and they set it. So this is what I was also talking about. They set it every 2 seconds. MVM3 erase all. In Home Assistant. Yeah, temperature sensor would be cool to get set up. Interesting. Interesting to see how they did that. So it's a Zigbee OpenThread Bluetooth system in package. Huh. Radio system. It doesn't have USB. That's why there's a separate SAMD11. It's an M33 256K RAM, which is not, like, CircuitPython would be okay in there, although I don't know how much space CircuitMatter takes up at this point. But no USB. Wah, wah. Okay, let's look at these other two. Hey, Jono. If folks have questions, I'm happy to answer them. I know I'm kind of tooling around because I'm in lame. Yeah, it's the most Friday of Fridays. I feel good with how I got on CircuitMatter. It was a lot of work, but just one foot in front of the other. And I do want to do Python next, I think, or CircuitPython. I think getting CircuitPython running CircuitMatter would be really cool. All right, so this is the G9, U5 G9 ZJ. 3 megabytes of SRAM, 4 megabytes of flash, which is insane. It's got parallel TFT, SRAM, NOR, and NAND solutions. It's got high-speed USB with an integrated PHY and power delivery. It's got an OctoSPI interface and a HexaSPI interface. These ones are kind of insane. It's got a GPU. This one's got a GPU in it. Who knows how well it's documented, but 160 megahertz M33, so it's similar to the RP2030 2350, sorry. And then for display, it's got MIPI DSI, TFT LCD, and a JPEG decoder. Maybe encoder too, I don't know. 3 megabytes of RAM. That's crazy. I might already have one. I'm a sucker for ST's dev kits. One day they'll get me. This one I think I might have as well, the G4 series. M4 at 170 megahertz. Has USB, full speed, but also power delivery. 96K SRAM, not really worth it. Although, one reason the G series always caught my eye is that they come in really small packages. This one not so much, just down to 48 pin, but you can get them down to like 8 pin. The G0s come in like 8 pin packages, which the G4 series I guess won't show me here. The access line comes in 32 pin. And these top ones would be CircuitPython ready. So the G491 could run CircuitPython okay. 112K RAM in a 32 pin package. So this is like, the reason I was thinking about this is like the Gemma and the Trinket are pretty small package sizes. Although, yeah, these have USB. Uh, 48 pin. 48 pin. But the G0 value line goes down to 8 pin. And then my Stemma G0 stuff uses the 20 pin TSOP. But then you can actually go with the 32 pin LQFP, you can get all the way up to 144K of RAM, which would be cool. Jono asks, do you have a favorite currently supported CircuitPython chip, one you reach for noodling around with a new project? My current favorite is the ESP32S3. I think that's what I would say. It's got native USB, it's got BLE, it's got Wi-Fi. It's pretty quick. It's got external PSRAM support. I'll tell you, I have this like Pimoroni Inky frame on my desk that is running my like weather display, and I would love. The thing that I would like also is I would love an S3 e-ink friend. So it's an S3 that has just the connector for e-inks on it. I think that would be really cool. And the S3 can do like that. That's what I would target for CircuitMatter first too, because Matter can run over Wi-Fi. So Wi-Fi, and then the S3 has the most resources to start with. So that's kind of what I was thinking about with CircuitMatter, is like I would do the S3 first. So yeah, that's my current go-to. The 2350 is quite good if you need what PIO can do. Like thinking about the Gameboy card again, like you wouldn't want an S3 really for that. You would want, because you're interfacing with a pretty relatively high speed parallel thing, like the Gameboy runs its data bus at like a megahertz. So like that's a case where you really do want the RP2350. But if you're doing any sort of network, like Wi-Fi or BLE, like S3 for sure. But also, I don't do a lot of CircuitPython as a hobby. Partly because whenever I do, I find bugs, and then it just feels like work. So a lot of my hobby coding is like Python, but not not Python on hardware. Although I've been thinking about if I need to get some programming desires out while I'm on leave, I might do the CircuitPython build stuff, because that's something I'd love to do, or the stem and G0 stuff I think would still be kind of neat. I'd love to do something with e-ink in the future. Recently picked up an S3 reverse TFT feather. Yeah, the built-in TFT feathers are nice too, but I have this e-ink display that I found. It's a 13.3 inch e-ink display for like $150. Like, it's not cheap, but it's like way cheaper than anything else. Maybe I've shown this before. It's a 4 grayscale 13.3 inch ePaper. And it's just a SPI interface. So yeah, it's $150. It's not cheap, but it's cheap for the size, and it has the interface for e-ink that we normally support. Retired Wizard says, I've been playing with solder 10-inch e-ink using ESP32. It uses an 8-bit parallel display. So far, I've been trying to understand the MicroPython library. I'm thinking I'll need to write a whole new display bus, possibly starting with the SPI bus to pass in an e-ink frame buffer. Yeah, I don't know what protocol they use. That's the cool thing about this 13-inch one, is that it's got a chip that works like our existing e-inks. There's one change I had to make to get it working. I actually got it working. There was one change I had to make that I haven't actually committed to CircuitPython, I don't think. It's like one of those lost branches on my GitHub that if I happen to get an S3 e-ink friend, then that's what I could do. But yeah, S3 is kind of my go-to right now. They're just they have so much RAM, they're quick, they've got native USB, but then they also have Wi-Fi and BLE. Like if you go to the C series or the H series, you lose, C series or H series, you lose the native USB. So no CircuitPython Lego brick color sorting project. No, I've I've pulled myself back from the brink of doing any sort of AI ML stuff. That was a short-lived thing. I'm about to have no time. I'm about to have no time, and one of the hobby projects I have is like tracking government stuff, like bills and things as they go through the legislature, and they're talking about closing schools in Seattle. So like, that's kind of where I would live if I did any hacking. I think ePaper is the future for anyone working in an office / large unit documents. Yes, that is something that I thought about a lot. Is I'd like to have an e-ink display. There's this guy Notro who did some CircuitPython stuff that actually he created this like basic display driver over USB, and I've been tempted to try to connect that up to an e-ink so that I can basically have an e-ink as a second monitor for stuff like that, but I don't know. How often do I actually need something that refreshes as slow as e-ink? I don't know. Certainly better for your eyes, I would say. Okay, so I did shopping. I don't know. Yeah, I don't know when the ESP32P4, if they have any more info on when their new rev's coming out. Definitely, like, there's stuff we could do in the high performing or the higher speed interface space. So DSI, CSI. Yeah, what they have here. So MIPI DSI, which is displays, like phone displays. CSI is cameras. I3C is a new thing that's meant to replace I2C, I2C. And then USB 2.0 with high-speed USB is something that we've had a long time with the IMX series, but would really like to see us do some more stuff with high-speed USB. I think that'd be neat too. I don't know. Let's see. We've got 20 minutes. Maybe I'll just call it early. I was tempted to do the MPY cross of CircuitMatter, but that is another whole large can of worms. Any other final questions before we go? I know there's not that many people watching, but let me know or post to the CircuitMatter issues if you try that. Dan and Jeff are around while I'm out to keep things moving. Reduction iScreen is huge. Yes, I like e-readers a lot with e-ink screens, for sure. Thanks in advance to Foamy Guy for taking over for me for deep dives. I guess I'm gonna end early because I'm done for a while. Thank you all for hanging out. Give CircuitMatter a try. Let me know how it's going. I'm sure there's lots of bugs. But I think the next big thing for me when I get back from leave is CircuitMatter on CircuitPython, depending on how much progress Dan has made on that. Have a great time. Thank you all. Thanks for keeping CircuitPython going while I'm out. And if you want to support me, you can go to Adafruit.com, purchase hardware there. Lady Ada and Phil and the rest of the Adafruit folks are super supportive of me taking this time, parental leave for having a baby. So they're a great company. It would be great. Please support them. Go to Adafruit.com for that. CircuitPython.org is actually getting a refresh as well. That'll happen at some point. But check that out if you want to know more about CircuitPython. Other than that, I'll do some window and we'll get out of here. So thank you, everybody. Have a great weekend. Have a good November. I will see you. I will probably be around in the bubble around Thanksgiving-ish / after Thanksgiving. Baby's not actually here yet, but due date's on Monday, so it's just like we'll just call it. Anyway, thank you all. Here's the beautiful weather. And I will talk to you in a month or so after I have a second kid. Thank you, everyone.